In this video, we're going to go over the last two steps of the conversion to Chomsky Normal Form and finalise it. Hopefully this video should be slightly shorter than the previous one because we don't have to go over the concept of Chomsky Normal Form or how the general conversion of grammars works. I only need you to remember the same things that you needed to remember for the last video, so make sure you've watched that video and then you'll be fine for this one. So to recap, the kinds of rules that we had that didn't satisfy Chomsky Normal Form were these four kinds. So we covered the first two, epsilon productions and unit productions in the last video. So at this point, if we've followed the methods in that video, we should have something that will only have either rules that are in Chomsky Normal Form, that satisfy Chomsky Normal Form, or rules that look like this. So the first kind are rules where the length of the right-hand side is greater than or equal to 2, and where the right-hand side has some elements from sigma, the terminal alphabet. So that could be rules that only have elements of sigma, or it could be rules that have a mix of terminals and non-terminals. Now, we call these mixed productions, but I think that that's a slightly misleading term. The textbook calls them mixed productions. And the reason is because when we handle them, we also have to handle rules like this, which don't have a mix of terminals and non-terminals. So really what we're dealing with is rules that are longer than 1 and that have terminals in them. The second set of rules are rules that are longer than 2, so where the right-hand side is at least 3 long, and where they only have terminals in them. Now we can straight away see that once we've looked at all the rules of this form, that will contain all of the rules that are 2 or longer, but only if they have some terminals in them. And this will contain all of the other rules that don't fit Chomsky Normal Form, because remember that a rule, say S goes to AB, is 2 or longer, but that's valid Chomsky Normal Form. So we only have to handle the ones that are 3 or longer, like this, when they have only non-terminals in them. The method that we'll actually use for dealing with each of these is, for the first kind, we're just going to convert all of the rules into rules that only contain non-terminals, and there'll be a really easy way to do that. And then afterwards, we'll let the second method handle all of the long right-hand sides. So the first method will actually rely on the second method being there to eventually turn it into Chomsky Normal Form. So the first one is called remove mix, even though I said that that is, in my opinion, a misleading name. What we do is we get all of the rules whose right-hand side is longer than 1, has more than one symbol in it, and that contains some sort of terminal in them. So for instance, maybe P goes to, I know that's an R, P goes to big A, little b, C. And what we do is we make a new rule for that terminal symbol called TB, which only has on the right-hand side the single terminal B. Now this is valid in Chomsky Normal Form, so we haven't added anything that's going to eventually violate anything. And then what we can do is we can replace the occurrence of that terminal with this new non-terminal, because all that is going to produce is that single B. So on the right-hand side here, we see parse trees for that. So at this point, we're able to produce anything that can be produced from a big A and a C with a B in the middle. And we want to get rid of that rule A, B, C and replace it with a rule that only contains non-terminals. And the way we can do that so that we end up with something that only contains non-terminals and still produces the same thing we could before is by adding this new non-terminal T subscript B, which produces a B. So for our particular grammar, one example rule like that is this rule here. This is interestingly enough, the only rule that is longer than 1 that has terminals in it. And the way that we'll still be able to produce all of the strings that we could before is by having something that does this. So we'll end up with only a rule that expands out to non-terminals, but we can still produce our string W equals AA. So what we do, we get that rule that is 2 or longer and has terminals in it, and we add a new non-terminal, t subscript a, that goes to a, and we replace the a in that with that. So we add the rule s goes to t subscript a. Then we remove this rule here. Now, a few words of caution. We don't modify this rule here, because if we decided to add s goes to just t subscript a, we would now have reintroduced a unit production, which we removed already. So the rules that are already fine by Chomsky Normal Form, we don't add. Also, you might notice that we've already got the ability to produce a little a from a, so why could we not just add s goes to big A instead of this new non-terminal? And the reason is because that would let us produce something of the following. So we originally had the ability to go to little a. If now we use going to big A, we end up producing things that we couldn't produce before, because we never had the ability to turn an s into whatever we could produce from 2 big A's. So we don't add any rules that have more than just that one non-terminal on the right like that. So the best way to remember this is just to follow the rule formulaically, and just simply, whenever you have a terminal in a rule that is longer than 2 on the right hand side, make a new non-terminal just for that one case, and then substitute. What we end up with over here is the resulting grammar, and we'll notice now that it has no rules that are 2 or longer that has any terminals in it. Finally, the only kind of rules that we have to worry about now, because we've gotten rid of all the unit productions, the epsilon productions, and the mixed rules, we'll only have rules that satisfy Chomsky Normal Form, such as these, or rules where the right-hand side is longer than 2, and where there's only non-terminals. So that's the only thing that we have to deal with, and we call these long productions. So for each rule that has n non-terminals on the right-hand side, where that number n is greater than 2, we create a set of new non-terminals, one less than that many, and we make a chain of rules so that we can still produce everything on the right-hand side of the original non-terminal using these set of rules that are only of length 2. So basically, if we have something like this here, where I've got p can go to a, b, c, then I replace everything but the first non-terminal on the right-hand side with a new non-terminal, which I'll call m subscript 1, and then I let that go to the bc. If I had, for instance, p goes to a, b, c, d, then what I would do is replace that with p goes to a with m1, and then I would have m1 go to b, m2, and then I would have m2 go to c and d. So we can see here that we only end up with rules that break into 2 non-terminals at any step, but I can still end up producing the entire thing that I could before with the original long rule. So concretely for our example, there is only one long rule that we end up with here, and that is a goes to c, d, c. So we remove that rule, and we add in a goes to c, m1, and then we add in the new rule m1 goes to dc, and we can still produce everything that we could before, because we can still go a goes to c, m1 goes to dc, which still lets us produce everything that we were able to produce before with just a goes to c, dc. But now we don't have any rules that are longer than 2. So our final result is this grammar on the left here, and I've rearranged it slightly from the grammar on the previous slide so that each line only contains rules of one form or another. So each of these we see, so when we look at Chomsky Normal Form, we know that we are only allowed to have either 2 non-terminals on the right hand side or one terminal on the right hand side, and you can see for each of these cases that this grammar satisfies that. Now what I would recommend you do is go back to the original grammar we had and see if you can produce a few strings from that grammar, and then just check that you can still produce those strings from this grammar. I would also look and see if there are any strings that you can recognise that you can't produce using the original grammar, and double check that they are not producible using this grammar here. Now, you'll note that if the original grammar, now in this case it didn't contain it, but if the original grammar let us produce the empty string, there is no way that a Chomsky normal form grammar will let us produce that, because the only way to do that is to have the start non-terminal go to EPS, and that is a rule form that we don't allow in Chomsky normal form. But every other string can be produced using a grammar with Chomsky normal form. So at this point, you should be able to take any arbitrary context-free grammar, G, and turn it into a new grammar, G prime, such that the original language, except for only the empty string, is produced by this new grammar. And that grammar is in Chomsky normal form.